All right, GM, everyone. Thank you guys so much for taking time out of your busy schedules this week to join us. My name is Evin McMullen from Billions Network. We are the first universal human and AI network built with mobile-first verification. Come on up. So today I am delighted to be joined by some incredible panelists. To get things kicked off first, I'm going to invite everyone to share who you are, what you are working on, and give us a little bit of context for the hat you wear when you come to the House of ZK today.
Okay. Thanks. Yeah, I'm Stefan from the ZKM. I'm the CTO of the ZKM, and ZKM is a MIPS-based ZK virtual machine that's targeting building the general purpose verifiable computation infrastructure. And currently, our use case includes the Bitcoin layer 2, like the Gold network, and some other even include some AI-related projects like the last AI. Yeah.
Hi, Anurag, co-founder of Avail. Been in the space for about 8 years now. Previously also built Polygon. Avail builds infra in the spaces of scalability and interoperability. So we just come out with this upgrade called Nexus, which we are focusing on now.
Hi, this is Michael from Brevis. At Brevis, what we're building is what we call the infinite computing layer for Web3. It enables your applications on blockchain to tap into an infinite amount of computation powers. So, there are two main products we built. The first is called Pico ZKVM. It is general purpose ZKVM that is extremely performant and developer friendly. So another feature it has is like extremely modular. So you can actually plug in something called a ZK coprocessor for many commonly used application scenarios. They work with many of the biggest names in the DeFi space, such as Linea, PancakeSwap, Uniswap, QuickSwap, and many others to build the application feature that is in production right now. With like hundreds and thousands of users hundreds of thousands of users are actually using them on a daily basis.
Hi, I'm Shiv. I'm the CEO of Boundless. Boundless is a universal protocol that brings ZK to every chain, every app, every builder, and every context. We were born from RISC-0, which invented the ZKVM and really sort of restarted the conversation around ZK and its applications. So yeah, super stoked to be on this panel. I'm also a graduate of NUS, so this is a homecoming from me. Lived here for like a decade, so yeah.
Excellent. So I'm particularly excited to be here with you guys today because you have a little bit of a different perspective, let's say, than the one that I build on. So with Billions Network, we're really focused on client-side proving, libraries like Circom, SnarkJS, RapidSnark, but we are now entering into a new era of proving with more of a commodity model and decentralization. So can you help us think about the journey? What has been instrumental in evolving from, call it 5 years ago, when if we wanted to generate a zero-knowledge proof, we were sitting at our desktop computer, crossing our fingers for 30 minutes and hoping something would happen, to the marketplace-based ecosystem that we have today?
Maybe I'll start. So I think Boundless is completely born out of these sort of market trends in a lot of ways. So key thing to remember is until maybe 5-6 years ago, or actually to be honest, 4 years ago, most of ZK was implemented using circuits, which required PhDs, in-depth understanding of what you were doing. If you wanted to actually do something in production, was just run something in your laptop. There's maybe 200 people who could do this properly, another 200 people who could audit this for you. So a very happy 400 people family, farming, a very small industry. ZKVMs actually flipped that narrative completely by allowing access to anybody who could write a high-level language to enter the domain of writing ZK programs. So accessibility. The next thing is improvement in proof systems themselves. Polygon famously, spent quite a lot of money acquiring the best ZK researchers, putting them together to improve the state of the art, especially with the Web3 context. And then there was other people as well, Eli, of course, and lots of other teams, RISC-0, putting forward newer proof systems that advance the guard, which makes performance something that is now in the domain of totally acceptable to getting even faster, and cost as well. The last thing is cost, right? So the most important thing that businesses pivot on is OpEx, cost. When you're actually doing something for real, like somebody has to foot the bill. It's all great for CTOs to hang around saying this is all cool and shiz, but there's a CFO standing at the back going, I can't really pay for this. Which is why we're entering the market era. Markets, and firstly, crypto and markets work extremely well together. The power of the token actually like reduces costs. And that is really going to be the entry point where we are going to welcome more and more users come in. So this is why we're all here, to build like markets for ZK and so on.
Yeah, I agree with a lot of what Shiva mentioned. So I just want to mention one thing, that we started in the ZK space from building circuits, which is basically writing mathematical equations, but then evolved into building general purpose ZKVM, where developers themselves don't need to understand anything about the underlying mathematics. And then, you can just write any kind of general purpose, program on top of that ZKVM and get that proven. But we also need to know that from a engineering and technology perspective, there's always this trade-off space in any kind of engineering solution, right? So like if we look at the entire ZKVM space, now we're operating the trade-off space between performance and programmability. So with ZKVM, general purpose ZKVM, we have the maximal programmability, but at the same time, undeniably, we're also sacrificing some performance. How do we fix that? Well, we now is actually coming back to the more specialized kind of a circuit architecture, where as long as you have a modular enough ZKVM, you can plug in, as if you're plugging some special hardware in your computer, you can plug in some special coprocessor in your ZKVM to deal with commonly used application scenarios and use cases, such as access to on-chain historical data and compute on top of that directly in your ZKVM. So this is like what Pickle and Brevis does here, is to have this kind of a modular architecture, but at the same time allow application developer to access the performance of specialized circuits for commonly used application scenarios. This is why we can actually have all these different kind of application use cases that is mass adoption ready, that were not available anywhere else.
Yeah, like to be honest, I think I mean I come from the customer side. Like I've been using RIS0. We've been using Brevis. We've been using Succinct, for example. We've been writing custom circuits as well, right? Like so we've used like the breadth, all the possible solutions. In general, like in concrete numbers, when we have like this bridge that is ZK based between Ethereum and Avail, that we first wrote in, we had to write in, we wrote the circuits. It took us 9 months, lots of audits, everything to kind of get there. Then once, the ZKVMs became ready, we rewrote it in. Actually, we've rewritten it in, RIS0's thing. We've written Brevis, for example. We've written in Succinct also, for example. And all of them took a few weeks, to kind of get ready. So to be very honest here, it's been like a very great performance thing for us. The thing that took us 9 months now takes us, like a few weeks. It's very easy to understand for our developers. We get more developers who can develop. Like I can just get people who write in Rust to write these programs. And so, but we still use, custom circuits when possible. Like the base layer of Avail still uses custom circuits because that's where we need very light logic and, very high performance. And so we use which is appropriate in that sense.
Yeah, I agree with most of the views that performance maybe is the biggest challenge for most of the ZKVMs by now. And but from my understanding that, I wouldn't say the end game. I would say the long-term goal of the ZKVM would like they build something like the verifiable cloud. So consider the last decades, how the traditional cloud grew up. So I think one of the most important is the developer experience. So how to make sure that ZKVM comes out because of its own now the developers to use high-level language like C++, Go now, or C#, maybe to write the sockets to build the applications. But right now, I think most of the ZKVMs are just focused on like the Rust, because it's bring you as a very short instruction sequence. But for the other languages like the Go now or some like the C++, I think that's one we are focused on to make sure the developers can use that. Okay, so this is the first point. We need to improve the developer experience. I think we support multiple language is very important. And the second one is, it's about the performance, I think. When everybody focuses on the RISC-V, maybe somebody may think RISC-V is the most suitable instruction set. But from our understanding, that's maybe not. We are focused on the MIPS, and we can take a look at the easy proof that the Xano is the ZKM's instruction set. That's the cycles of each block from Xano is about 10 to 30% less than the RISC-V based ZK virtual machine. So basically it can help us reduce the proving cost. For somehow. So that's the second one. We still think the performance may be one of the biggest problem right now. And that's what we think about.
So obviously, improvements in performance, cost, and efficiency are vital to this abstract idea of scaling. To make it a little bit more tangible, we had a spicy prediction from one of our brilliant colleagues in the Lagrange team earlier today that in only a few years, all compute will be verifiable as a basic expectation, and if it's unverified, it will be tantamount to non-existent. Do you agree that all compute should be verified, especially in the DeFi space? And if so, how on earth are we going to afford that?
Yeah, definitely. This makes me this reminded me about the containerization several years ago, maybe 10 years ago. Should everything be in a Docker or in a Kubernetes? I think the answer would be no, right? So for the ZKVM, I think that's would be a similar answer. Not every software should be proved or verified by ZKVM. But for the AI, I think especially for the agent, I think it's when the people some speakers are talking about they use the agent to do some like the prediction markets. For the transactions, it will be very important to verify the execution trace or the actions or the plans of those agents. So I think for the AI, it's very important actually, but performance is still a big problem right now.
Yeah, I mean, it's of course be very bullish if everything was to be verified. But to be very fair, I think most computation doesn't need to be verified. Like there is a market for computation that is important, and there is a market for computation that is not important. So blockchains are basically compute that needs to be verified, right? You want your money flow to be verified. Do you want I don't know, sending your stickers, emojis to 10 people be verified? I don't know. I mean, whether that should be verified, right? And of course, everything is a cost, right? I don't think there is a world where running one cycle of computation natively and versus verifying that requires, of course, multiple cycles, right? I mean, again, it comes down to a lot of things. Of course, anyone can make these predictions like everything is going to be verifiable, but I don't really think so.
Wait, Anurag, I have a follow-up there. So you've noted that on the one hand, of course, financial transactions warrant verifiability. That seems like something we can all agree with. We want to ensure that our money is only engaged in verified transactions. Then on the other hand, we've got sending stickers around. Those seem like two agreeable poles. How do you draw the line?
Cost, I would say, I mean, that's a very easy way, right? Like, I mean, essentially, even right now, right? Like, we have to look at cost very succinctly, right? Like, for example, if we are using a ZK prover from RIS0 or from Brevis, or do we have to run our own? Do T's kind of suffice for this use case, for example? Because there's always a dollar cost attached to everything. So I think cost is a very easy way to kind of filter. I mean, just compute the number of the dollar revenue that these guys will make. If I had to verify liking or sending emoji stickers or liking a social media post, for example, these would be the most valuable companies in the world.
Yeah, I think for that prediction, I want to refine that prediction a little bit. And I think that will make it valid. That is like, I think in 5 to 10 years, 99% of blockchain applications, as computation is actually going to run in an off-chain, verifiable, ZK-powered way. Now, the reason for that is that, the amount of computation that is actually accessible on-chain today is actually very, very, little. So like, let me give you guys a very, very concrete example. So if you have used any kind of a centralized exchange today, you probably all seen this feature that is like VIP trader reward program. If you trade it a lot in this month, then in the next month you get a trading fee discount, right? So every centralized exchange has this feature. Now, think about it. Think of all the decentralized exchanges that you have ever used. Have you had any kind of exchange that offered this feature until very recently, until we work with PancakeSwap, for example, right? None of them offer this feature, not because they don't want to, but because just to compute individual users' trading volume historically on chain is going to bankrupt you in gas fee. So this is how little computation power you actually have on chain. And this is why we need to change it with verifiable computing that can allow you to offload this kind of a complex computation away from your smart contract to an on-chain environment, then bring it back to the blockchain so smart contract can verify that easily and cheaply. So this is why we're powering like a lot of intelligent DeFi features such as PancakeSwap and Linea and Euler and Euromoney, helping them to launch new programs to customize user experiences for their user, to distribute the reward based on very complex user behavior on chain in entirely trustworthy way. This is what we're doing with Brevis now. So for now, we're kind of having application that is half on chain and half off chain. Most of the, half of the business logic still runs on chain. But I think in just a few years, we're going to see applications have most of their computation logic that happens actually entirely off chain, such as like, we're working with like major perp DEX recently to launch this kind of a ZK perpetual swap where you can have centralized exchange user experience, but at the same time with privacy protection for your order and positions. So you can have like dark pool orders, you can have like hidden positions. So there's not going to be any kind of a liquidity assassination that you guys seen on the kind of a James Wayne case, right? So this is where we see the industry going, and this is where we are pushing forward to.
Yeah, I actually agree with Anurag to like a really large extent. Whilst I would love to be the most valuable company on the planet, I think that's maybe like taking it way too far. Because ultimately people are driven by cost. If you have like a cheaper option that is acceptable for your requirements, then that's where you should go as a responsible builder, because it is passed through cost to your customer. And generally how markets function is, if I blatantly make my app more expensive, somebody will find a way to build a cheaper app and like kick me out of the market. So I think there's always going to be that trade-off. I have a different perspective on this, which is, so I'm both a CS grad, but I'm also an economist by training. What will actually happen is the size of the pie itself will increase. I used to work at AWS and Azure when like the whole war cry was all computing will move to the cloud. It didn't. A lot of it did. A lot of the new computing moved to the cloud. It created more opportunities for people to build highly scalable business models, new kinds of applications. Netflix runs completely on AWS. Most people don't realize this. But data centers, if you know how much power you need, if you know how much compute you need, data centers are the way to go. You're always going to find it cheaper. It's easier to be compliant, all the more interesting things as well. But similarly here, what's going to happen is as verifiable compute becomes cheaper and cheaper, as ASICs become a reality, as client-side proving becomes a reality, more use cases will show up. We will eat a dominant share of these use cases that have been built around this capability. Because when you think about it, it didn't exist because verifiable computation wasn't cheap enough. Verifiable computation becomes cheap, these use cases come in. Obviously, it means that they need verifiable compute. So you will see the market cap of like verifiable compute increase, and that's great news for us. The world that I want to live in is where like all of these options are available to me as a builder, and it is native in my DevX experience as well. When I'm writing my application, if I can switch between verifiable and not verifiable in like some kind of metadata in my code itself, and I'm like, oh, this is a very critical piece, I want to run this in verifiable infrastructure versus this, and like I just start splitting it out. That's what you're going to see. And I'm really hopeful for that future as well, because it does build more engaging user experience. You want to build really quick user experiences for everybody that are slick and easy to use, but also provide the security that you need. Not necessarily just blockchain, but like off-chain as well. Like, yeah.
So Shiv, you said something a little spicy there, that trust assumptions will adjust to the requirement of the use case. Let's talk a little bit more about that. So, I think a number of these forthcoming and even present use cases, especially those in DeFi, imply that there exists more than one chain, right? We live in a post-Bitcoin world, and so interoperability is the elephant in the room when we talk about these trust assumptions. How are you guys thinking about that interplay between the interop requirements of scaling, concepts like unified liquidity, and how we moderate the trust assumptions of building in between these different ecosystems?
Yeah, I think interop for a while had died down in its conversation because people have just accepted that this is what oracles are, this is what bridges are, just deal with it. But the advent of ZK, or like rather its presence in the conversation, and the price point at which proofs like on Boundless, for example, during our mainnet beta, the median price of proofs was $0. So people were willing to speculate on the token so much that they discounted the cost of the proofs to $0. P90, 90th percentile, was also $0. P95 was also $0. I don't expect that on mainnet, but what we are seeing is 90% discount. So the cost to go down, and which means like people are willing to do these gigantic proofs of state of Ethereum. For example, we built a full consensus client for Ethereum, not a light client, but a full consensus client, previously thought to be not useful because the proving of that would be so expensive. We've been able to do that, which means you can carry Ethereum proof to any other chain. Let's say we do that with Solana, now you can carry that. So if we are able to actually do that for most of the major chains, we encourage people to launch app-specific chains, because maybe it can be argued, but I don't know how you'd win the argument that like having a custom chain for your use case is not better than having a general purpose chain. Like I think just intuitively makes sense to me that having your own custom block space is important. And if you can make interop extremely cheap and easy to do for you to plug in your own custom block space, all assets will become multi-chain, in my opinion. Not that they need to. I also think it's kind of silly that like if every asset is multi-chain for no rhyme or reason, you just, it's a hat on a hat, as the stand-up comedian would say. It's not necessary, but the capability will exist. And I think as an end user, I am not super concerned about where my asset lives and what I have to do. Right now, I have to do my own bridging and do all these interesting things to use something on Solana because my asset is on some other chain, and do all these like hilarious things that actually adds a lot of onboarding headache. I'd much rather be able to open an app where I'm just like, I have these assets, I want to use this app, I want to do this thing, I want to get this yield, just do it. Don't bother me with all the other execution details. Funnily enough, that's how Web 2 operates, isn't it? When you connect your bank app to Wealthfront or use a robo-advisor or all these things, you don't really worry about like, oh, how are they moving the data around? Like, am I supposed to do more things? You just authorize. And you just like things just move around. So that's really the world I want to live in. And I do believe ZK unlocks this because costs have gone down enough, and you can do this at scale with decentralized proving networks like Boundless.
Would you guys agree that interop is I'm just asking our other panelists if they agree that interop is useful based on the pull, based on the demand for that interop?
Well, I think interoperability is kind of a secondary demand. Interoperability's demand stems from the need to have scalability, really, right? So because we cannot scale layer one blockchain fast enough, this is why we actually can now break, many break into these many sort of isolated islands of layer twos and separate blockchains. And I think my take on this is if we want to fix interoperability, we need to actually come back to the layer one blockchain. And if we can scale the Ethereum layer one blockchain by another 100 times, even 1,000,000 times, then we basically have the interoperability solved. We can actually enshrine all the validating clients for the layer two into the layer one itself, so everyone can have synchronized communication between all these different shards, different kind of islands in the Ethereum or any kind of a blockchain world. Now, there's a reason we couldn't do it today, because the Ethereum, again, layer one doesn't have enough computing power to do that. Well, what's the fundamental reason for that? Well, the fundamental reason that we don't have this capability is because today's blockchain consensus runs on something called a simple computing. That is you have a verification of the computing by only doing recomputation. So you have 1,000,000 nodes in the network, right? So you want to have this 1,000,000 node reach the same conclusion for some kind of a computation. What we're doing now in every blockchain is to have every node in the system does the computation again and again and again and again. The same kind of a computation get repeated 1,000,000 times. Is the time is the cost of that is basically 1,000,000 times more than the single unit of computation, right? So how ZK can solve this is by allowing you to just pick one node out of that 1,000,000, generate a ZK proof of the computation, spend maybe 100 nodes worth of computation power on that. However, you save the cost for millions of replication of the computation, because everyone else can just verify the proof of the computation with extremely low cost. A very, very important benefit of ZK is that no matter how complex the original computation is, the cost of verification stays constant. So this is how you can actually build a Ethereum future, for example, that matches the capacity and speed of Solana while still maintaining maximal decentralization. Once you have that, you can essentially have all your layer twos share the use kind of a shared sequencer with the entire Ethereum blockchain to become essentially based or native rollup, right? So that will give you a level of interoperability that is just simply not possible to do today. So we actually think that this is something that Pico has been working on. To achieve that, you basically need the first step to do that is you need to prove Ethereum blocks in real time. And we're gonna launch something very exciting very soon on that front for Pico as well.
Yeah, I mean, one of the main reasons why we began Avail in the first place is Ethereum blockchain like Ethereum doesn't really have native interoperability, and for some of the reasons which Michael already kind of pointed out, it's very hard to kind of bolt in something like native interoperability. And so it's very hard. If you see, there are probably 200, 300 layer 2 chains on Ethereum today, but all of these look like separate islands. Each of them have their own liquidity, own assets, and then everyone has to go back to the mothership Ethereum to kind of bridge funds, for example, and so on, which was actually okay a couple 1 or 2 years ago, but there's now a lot of competition, from, let's say, things like Solana, Hyperliquid, for example. So now there are these new islands forming. And so it's not really necessary that Ethereum and its own L2 ecosystem is going to kind of latch on to the legacy adoption they had. So interop is a very serious problem in general, right? Because funds are moving from one ecosystem. I mean, if you see the Plasma launch, right? Recently, it's a new L1, but insane amounts of money capital moved from the existing ecosystems to the new ecosystems, even though it has nothing to do with Ethereum, for example, right? Like so, and with the advent of TradFi, there's only going to be more chains. Like each TradFi ecosystem company is looking to do a stable coin. Each TradFi company is looking to do an L1 chain or an L2 chain. I mean, whether it is ZK, optimistic, doesn't matter. But there's a chain coming, there's a stable coin coming. By end of next year, I would say there will be probably 500 different stable coins on the market, like USD A, B, C, D, E, Z, whatever, right? Like so, and I mean, I'm not joking. It is right, like. And how do you interoperate between these new chains? How do you interoperate between stable coins, right? Like, how is a USDC or A going to be compatible with USDC Z, for example, right? Like, are they going to are you going to have to trade on a curve with like multiple of these pairs, for example? So there's a lot of questions around it. Coming back to the ZK question, when we started Avail Nexus, which is our interop upgrade, we actually meant it to be ZK native on day one. But the reality is that we don't have the kind of ZK rollup or ZK chain verification proofs on all chains, right? Like there are hundreds of chains which are either optimistic or pessimistic or L1, which we then now to go and find what consensus do they use. We need to create proofs for each of them. So it's a very messy task. So that's why us and even other teams have do now this combination of ZK, but we also use T's, for example. We also use like things like validator level consensus, for example. So at the moment, I would say ZK is not there yet, not from a tech perspective alone, but also from a business perspective alone. Like Base is not ZK enabled today, for example. Like something like Plasma or Hyperliquid is not ZK native ready today. So then we have to resort to other methods. But I'm saying interop is essentially like a foregone thing. It has to be solved. Today it will be done with a mishmash of technologies, but of course on like at in a few years we want it to be completely ZK, because that's very easy to manage as well.
Okay, it's still about the interoperability, right? Okay. Yeah, so basically at the beginning of the ZKM, we were trying to build the ZK verifier for the Metis layer 2, because Metis layer 2 origins is a optimistic rollup, so the finality time would be like 7 days. So we want to build some hybrid rollup that uses the ZK proof to reduce that finality time. That means when some people want to withdraw their assets from layer 2 to layer 1, we can generate a proof and to convince that the on-chain fraud-proof VM that those transactions have been included and be verified. Okay, so after that, we begin to consider the interoperability with different blockchain like the Bitcoin. Yeah, that's why we also spend a lot of effort on building the BitVM and BitVM2. BitVM actually is you can consider it as a smart contract of the Bitcoin. Yeah, it's more powerful than the script. Okay, so we also have we also apply this design implementation on the GOAT network. GOAT network is a Bitcoin layer 2. Okay, so actually we have a vision that we want to build something named entangled wrap. That means if in the long-term run, I think every blockchain with roll-up maybe becomes a based roll-up. That means use the layer 1 to sequencing ordering the transaction of the layer 2 and then verify the proof of those transaction, layer 2 transaction executions. Okay, so at that moment, that means every blockchain can produce a proof as the evidence that to the source or the destination blockchain that this transaction have been included and verified. So you can trust me. You can unlock the assets or lock some assets on the other end. Okay. So basically, the integral app aim to build such a protocol to make sure different blockchain can use proof as the evidence for the other blockchain to move or add the liquidity, something like that. Yeah. Okay. So basically, you also need something like the CCIP to format the message. Okay. So yeah, basically that's the interoperability about multi-chain ecosystem supports. And another thing I just I just have in my mind is the interoperability with the real world applications. I think this because it's very useful for the real W assets application. Yeah, because it's also an answer to your previous question. Should we prove every software? So one thing is that we have something right now we cannot prove, right? For take the operating system for example. We can prove, maybe we can prove the thread, multiple thread by library operating system, but we cannot prove the interaction between the operating system and the hardware, right? Because we cannot prove the data from the network or from the other hardware that is correct or is follow up some rules. So that means we for the ZKVM right now, we still need some abstraction between the improved word and the approved word. Yeah. So that's another things I have in my mind about the interoperability right now. Yeah.
Awesome. Well, thank you guys all so much for your time and attention today. Thank you to our wonderful panelists. It seems like we are in great hands when it comes to scaling and moderating our trust assumptions across chains. My name is Evin McMullen, and I will see you all on chain.